Welcome back. So, page 303. Alright, I don't wear the same clothes every day. I just film the same movies on the same day. Just so you know. Okay. Page 303, Pythagorean theorem. And then you notice, that's all I have written there, because the whole distance formula, we're not going to do that, because it's something that is not repeated anymore, and it's not really necessary. It's just another way of using the graphs that we've done in the past, which we've already covered them, and we've already talked about it. It's just doing it in a different way, so don't need it. So the Pythagorean theorem. All right, this is a little introduction into geometry, which I'm pretty sure all of you have to take next year, so yeah, good luck. All right, but the Pythagorean theorem basically has to deal with a right triangle. A right triangle is a triangle that has a 90 degree, right, 90 degrees, all right, and then it has, that's a right triangle, 90 degrees, all right, that little square means 90 degrees. If you measure it with a protractor, don't measure this one, you would get 90 degrees, okay? So the Pythagorean theorem has to deal with this and how to find the length of this leg right here. Now, a triangle is made up of 3 legs, right? This is leg A, this is leg B, and we don't call that leg C. The big long line, diagonal line, that connects a right triangle is called the hypotenuse. Hypotenuse. Say that with me. Hypotenuse. Can't believe some of you didn't say that. Come on. All right, so hypotenuse, all right? That is the line, the longest line that connects the 2 legs. Now, a man, and we'll read it, during the 6th century BC, right, a group of Greek philosophers led by Pythagoras generalized and proved a principle known as the Pythagorean theorem, which we're talking about 2014 years later. In mathematics, a theorem is a statement that has been proven to be correct. Geometry. The Pythagorean theorem is true for all right triangles and states the sum of the squares of the 2 legs is equal to the sum of the hypotenuse. By definition, a right triangle has 1 right angle, and then it has a hypotenuse, which is the longest side, and the 2 other sides, which are called legs. Here's a formula that Mr. Pythagoras developed, which is the Pythagorean theorem, which is a squared plus b squared equals c squared. You say, why are you talking about geometry in the middle of algebra? Because it has to do with all the stuff that we're doing right now, so it prepares you for next year. But we have to use square roots. So what they can do is they can tell you the side of the 2 legs, and if they do, you'll be able to solve what the hypotenuse is, the long leg. They give you an illustration. They say, all right, let's say that this is 4 feet and this is 8 feet. How long is this? Well, we just have to use the formula. We go over here. A squared would be 4 squared plus b squared, which is 8 squared, equals c squared. Okay? Now, 4 squared is 16, plus 8 squared is 64, equals c squared. 16 plus 64 is going to give us 80. All right? Now, we can solve that by finding the square root of it. The square root of c squared is c. But what I do to one side, I have to do the other. What's the square root of 80? Well, there is no perfect square root of 80, so we go up here, and we think of a perfect square that would go into it, all right? And so I'll just cheat and look down here, all right? See, found it. All right, so 16 times 5 equals 80. All right, the perfect square root of 16 is 4. So I have the square root of 16 times 5. And so I have 4, that's the square root of 16. 4 times the 4 times the square root of 5 is equal to c. That's the Pythagorean theorem. And you say, this is so ridiculous, why do I have to learn it? And I always use the same illustration, but the reason why this is so important is because if you've ever been to Greece, or they have an entire way of building named after them, all right? The Romans used it, and pretty much we use it still to this day, is this formula. The reason being is because it helps keep everything perfectly square. And so if you ever notice, they always have columns. Their temples are always built in rectangles and squares, and they're perfect because of this. Right? Even us, when we had to make a soccer field last year, Brother Ezra and I, we had to make sure it was, you didn't want it to be like, right? So we wanted to make it right. So we knew the dimensions of a soccer field. We knew it was, however long and however wide. And then we used the Pythagorean theorem to find out how much this should be, which made it perfectly rectangle. And we made a perfect square. We actually used this. We used algebra. I know, shocking, right? So, but that's all the formula is being able to find the length of the hypotenuse using your square root, right? They give you another illustration on the next page, but skip it. Let's go do some, right? There's only a few of these, so it's pretty simple, all right? So the first one says this, all right, in numbers 1 through 8, they want you to find the value of x in each right triangle, all right? So, like number 1, they tell you that one leg is 8, one is 6. So you're always going to use this formula. A squared plus b squared equals c squared. Okay? So they want you to find that right there. So we go here and we fill in the a for number 1 is 8 squared plus b is 6 squared equals c squared. 8 squared is 64. 6 squared is 36 equals c squared. 64 plus 36. 6 plus 4 is 10. It's 100. All right, so c squared. Then you find the square root of that, square root of that. C equals square root of 100 is 10. All right, so 10's the answer. Now, what they're going to do is they'll throw in some, odd ones that don't quite work out. And you just take it down as far as you can. If you can pull out one of those, like number 2 says your dimensions are 8 and 1. All right, so I have 8 squared plus 1 squared equals c squared. A squared plus b squared. That'd be 64 plus 1 equals c squared. Square root. The square root of 65, all right, is c. Is there a perfect square? Well, 2 squared is 4. 4 won't go into that. 9 will not go into that because 3 squared. 4 times 4 is 16. 16 won't go into that. 25 won't go into that. 6 times 6 is 36. It won't go into it. 7 times 7 is 49. It won't go into it. So nothing has any sort of perfect square. All right, so that's the answer. The square root is 65. So some of them will come up with a number. Some will have the square root of, just like this one. Some you may end up with something like 3 to the square root of 2. All right, but if you do, it's fine. The only thing that may throw you off a little bit is they use the same formula. A squared plus b squared equals c squared, but they don't give you the same dimensions, such as number 7. They give you a squared is 8, so 8 squared plus b squared equals c squared, and they tell you on number 7 that the c is 10. All right? So you just fill in what you know and then solve. 8 squared is 64 plus b squared equals 10 times 10 is 100. I'm going to subtract 64, which gives me b squared equals 36. Square root of b squared is b equals 6. So I found the other leg. All right? So that's what you're going to do on numbers 1 through 14. All right? They just don't draw the pictures for 9 to 14. Okay? So that's what you're going to do on numbers 9 to 14. I'll pick another one. Let's just do number randomly. Let's do 13. Let's make it hard. All right? 13, and then I'm done. You got the rest of these. All right? 13 says, I know one leg, I don't know. We'll call that a squared. Plus b squared, they give me on 13, which is 8. So 8 squared equals c squared, and the hypotenuse on that one is 14. So 14 squared. All right, so I have a squared plus 64 equals 14 times 14, which is that 196? I think. Let me see here. 4 times 4 is 16. Carry the 1, 4, 5, 4, and 1, 6, 9, 1. Oh, yeah, I'm so good. All right, so 196. I'm going to subtract 64. Subtract 64 leaves me with a squared equals 6 minus 4 is 2. 19 minus 6 is 13. 132. Then I have to find the square root. So a equals the square root of 132. Now, before I just write that off and say, well, that's the answer, I have to ask myself, will any of my perfect square roots go into it? My perfect square roots, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49. You get the picture. Will any of these go into 132? Well, let's just start with the 4, all right? Will 4 go into 132? 4 into 132, 3, 12, yes, 33 times. So I know I can do this. A equals the square root of 4 times 33. The square root of 4 is 2. So now I have A equals 2 times the square root of 33. Can that be broken down any further? Well, can 4 go into 33? 9, 16, 25. I'm already past the number, so that's it. So A equals 2 times the square root of 33. So you would put in for number 13, 2 square root of 33. All right, so all I want you to do for the rest of this lesson is I want you to do on page 306, numbers 1 through 14. 1 through 14 on this page. All right, and then for Wednesday, look over, you're going to do page 307. All right, page 307. And you're going to use your book and look back and try to find the answers, all right? But I want you to do numbers 1 through 54. Obviously, you can do that now, all right? Not like you can just say, all right, I'm done. You can do this whenever you want. You can start it yesterday, I don't care. But 307, I want you to do 1 through 54. That's Wednesday's work. Friday's work is a test over chapter number 8, all right? So you had Monday's lesson, then today's lesson you have to do those few questions. We've already done a bunch of them. Wednesday you do the review section, page 307. Don't do the bottom, the distance ones, don't. And on the test for Friday, if there's a question on the distance, which there will be, skip it. Don't do it. Who cares, right? All right, so that's the whole week. Isn't that awesome? I think it's only like 30 minutes in videos for the whole week. So have a good week. I hate this. That this is what it is, all right? We'll get through it. I limited your school year. I guess you saw that, all right? I took off the last couple weeks there, all right? Because it is what it is. But, get through it. Get through the summer. Have a good summer. And then we'll hit it again next year, all right? If you have a question, please let me know. I'll help you out.